Okay, let's say this is all you see. And we've got to make some choices. Okay, it says, what pressure in atmospheres? So let's read this, because I think one of the hardest things for the students to do, let's see if I got my point. Here it is. One of the hardest things for students to do is not doing that. I mean, you pay your dues, you know those equations. And then if you decide, it's a changing condition, you know how to plug that in. The issue is reading this junk. So, let's go through together and let's make a decision what we're up against. Because we got 3 whole lines of stuff to read. And sometimes it's more than that. It says, what pressure in atmospheres is exerted with 54 grams of xenon in a 1-liter flask at 20 degrees Celsius? Now, really, that's probably all you would see as your test question. Because the rest of this stuff I have typed in as hints. As I say, check your units carefully. I'm not going to say that on your test question. Pressure must be atmospheres. Mother Cartwright is not going to add that. Okay? So, volume must be liters, temperature must be Kelvin, and I even gave you R there. That junk's not for free in 48 hours. Okay, so all you get in 48 hours is the first line. So let's pull the guts out of that. What do we need? Well, we're looking for pressure. So I take what pressure in atmospheres. So I take that first 3 or 4 words there and I'll turn it into that. Then I say I have 54.0 grams of xenon. Okay? And I have a volume. The volume for that is 1.00 liter, and my temperature is 20 degrees Celsius. But what should I do before I even lift my marker? Add 273. Just get in the habit for this chapter. Don't even just write it down. Immediately switch it. So we've got 293 Kelvin. Okay, you look at just that much. That is all you got. Do you see changing conditions? Pedro, you were so good the first time. Do you see them this time?
No.
No. It's just, here it is. No temperature change, no pressure change. So the question is, well, first of all, we know we don't need that thing. The question is, would you prefer 5 or 6? 6. Marco, why did you choose 6?
Because it breaks down the moles.
Yeah. Okay, now, if you do choose 5, either one's going to work. If you choose 5, then you can do a quick grams to moles out as a separate problem, like you were back in chapter 2. But if you go straight into here, if your math skills are good to manipulate on the calculator, I'd go with Marco and I'd say, let's do this. So we have pressure. We do not know. Now, is our volume, pretend you don't see that second line up there. Volume 1 liter, is that okay?
Yes.
Yeah, it's great. Plus, I like the fact it's liter here, and it's 1. That's going to make the math a little easier. And we have 54.0 grams. And molecular weight is kind of a misnomer here because we're talking about an element. So what we need to do is really say atomic weight. But let's go for at least 1 decimal place. So for our xenon there, Nina, what do you see?
131.3.
131.3, and that's grams per mole. So if you do it out separately, remember how in chapter 2, I told you this would haunt you forever, grams to moles and back again. Here it is again, and it's going to be in 1412 and organic. Okay, so grams and grams cancel, moles coming around on the top. Do it out separate if you wish. Now, without looking up there, I want to hear your rendition of R.
0.0821.
Okay, and you don't have to worry about units, but I'll put them here for you because I want to convince you. Liter, atmosphere, per mole, Kelvin. Okay, right away, remember how mole would come around on the top? That means mole, and mole got trashed already. then our last thing to put in is temperature, which somebody switched for me, 293 Kelvin. Okay, Kelvin on the bottom, Kelvin on the top. Okay, we have liters over here, so if you wanted to, you could say, all right, that liter is going to cancel with that liter. And all that's left standing is atmosphere, which is as it should be. So, you want to divide this, get an answer, multiply by this, get an answer, multiply it by that. And when you punch that all through, how are we doing? Meredith, tell me what you got. Don't use the one from the book. Did you punch it? Okay, punch it. Andrew, what? 9.89. Give me some units, Andrew. Okay, ATM. Is that what other folks got? How about SIGs? Do you like your SIGs? Okay, they're good. 3. Okay, everybody with us on that? Okay, let's take a look at the next one down there. Okay. 12-9. Okay, for 12-9, what volume of a gas balloon filled with 4 moles of helium when the pressure is 748 torr and a temperature of 30? Okay, first thing you want to ask yourself is what?
Changing
Do you see
conditions.
changing conditions?
No.
No, we do not. Okay, so, looking over what they gave us, Liz, which equation up there would you like to use? Actually, this problem is a little easier than the previous. Liz,
Just without the temperature.
not without 5?
No, I don't know.
Okay.
5. She's saying 5, so.
Okay. Do you all agree?
Yes.
Will 5 cut it? Yeah, I think 5's a good choice. Because 5 is a good choice, because they give us moles up front. Okay, why was 6 a good choice that Marco told us last time? Because they gave us grams up front. So that's why we use this one. But of course, this is just a takeoff of that one. You don't have to memorize a separate one. Okay, so PV is equal to nRT, what my students in one class used to call the pervert equation. So we have, let's look up there and sort through. May I use 748 here?
No.
I'm hearing yes, and I'm
Yes.
hearing no.
It has to be atmospheres.
Okay, can we use torr in this equation exactly?
No.
No way. How do we switch? Okay, let's assume you're good on your calculator. I've got 748 torr. How do I switch it to atmospheres, Brittany?
Divided by 760.
Exactly. You divide by 760, and here's why. Because it's this many torr per atmosphere. Or you can think of, I've got what fraction of an atmosphere. Or you can do this out separate if your calculator skills aren't real slick. Okay, so this, torr and torr will cancel. Atmospheres come around on the top. Let me take you over here. Do you see this business? 1 atmosphere is equal to 760 torr. You are back in chapter 1. Okay, that's a statement of fact from chapter 1. Actually, it was not in chapter 1, but similar. We have 748 torr. If you were in chapter 1, and here would be your problem. Okay, if you want to set it up similar, the unit analysis we used back in chapter 1, in your first set of parentheses, we put whatever makes the problem unique. Then I take this statement of fact, I make a conversion factor. Okay, where do we want the 760 torr? On the top or on the bottom?
Bottom.
Bottom for sure. 760 torr, because you want torr to cancel. So if you're shaky on this, do it the old-fashioned, long, laborious way. But look, this is what Brittany told us up front. Just go divide. And you can do it in one step. Andrew?
So, The pressure always has to be in the 18 units.
For this equation, yes.
Okay. And
Yes.
the temperature always has to be calculated.
Always, always, always.
And which one does it not need to be in?
Okay, when it doesn't matter, because V is showing up on both sides, it can be mils, liters, quarts, pints, I don't care.
Okay.
Pressure, because it shows up on both sides, torr, atmosphere, bars, whatever, newtons, whatever physics folks use, I don't remember. But it doesn't matter. Okay, on test day, you go, oh my God, does it have to be, does it not have to be? If you will always go to atmospheres and always go to liters, you will always be right. But down here, you'll be doing some extra work sometimes, but you'll always be right. So when in doubt, go to liters. When in doubt, go to atmospheres. And you know, no doubt at all, you've got to be Kelvin. Okay, so we come over here. We'll just do this in the one big thing. Okay, now it says, what's the volume? That's what we're looking for. Okay, without even doing a unit analysis, we know the units on V will be what? Liters, for sure, because we're using the ideal gas law. All right, then, and, hey, they made a gift. So, Hina, what's in?
4.
It's just 4 moles. Okay, for anybody that didn't speak before, I want to hear R from the rest of you. Let's hear it without looking over there or looking at your notes.
8.
I'm going to assume I heard that right. All right. Now, you know, if you repeat something 5 times, it's yours for a week or 2. Repeat it 10 times and it's for life. Well, you got another week and a half to go. So say it several times, you'll have it. Okay, temperature. Let's look up there. We're at 30 degrees Celsius. So, Allison, what's that temp? 303 Kelvin. Okay, as we went through, we were super careful with units, and so you may want to divide this out separately before you whip it to the other side. You just want to be really careful with your operations. This is the part in the semester where people screw up on the calculator a whole lot. So that's why you're practicing with me today. So Nikki in the back, what'd you get?
As the final answer,
Yeah.
101 liters.
101 liters. Okay, do we like our 6? Charles, you like our 6? Okay, because we got 3 all the way up there. She gave us 3. She gave us the right units. Perfect.
So we don't count our first 6.
Your which 6?
We don't count our first 6.
That has 3. When you take it as .0821, that's got 3. And if you noticed, most of these problems run with 3.
Yeah.
Yeah.
Is that R value on the calculator?
No, I would doubt it. I don't think I've ever seen it. Has anybody ever dug it out of the bowels of your calculator? Okay, I don't think it's there. I don't think it's there. That's why Ruben also checks to see if people enter useful little tidbits. Years ago, I figured if people were that slick, but now all of you are getting that slick. If you have a calculator. Yeah, I don't either.
I'm not that slick.
So, okay, good. Now, let's go to the next problem. It's actually in the next section. No, I told a fib. I want to do 1211. It's still in the same section. This is something I don't believe I showed you last time. I want you just to watch for a few minutes. I want to take this. PV is equal to G over molecular weight RT. Okay, now just sit back and watch. Don't bother to write this down. Just follow the math. Okay, I'm going to multiply both sides through by molecular weight so that I get it ending up over here. So pressure times volume times molecular weight is equal to GRT. Okay? Now, I want to divide both sides through by volume. Years ago, when I used to watch teachers do this, I'm going, why do they do that? Because they know where they're headed. See, I have the end plan in mind. I'm not just randomly moving things around. I thought they were just randomly moving stuff around and aha, something fell out. Okay, I'm doing this for a purpose. So I'm going to now divide both sides through by V. So, of course, that clears it over here. And when I move it over, I'll be dividing by it, but I'm going to group stuff really carefully. Okay, if this is the same as if I had GRT over V, mathematically it's the same. G over V, what is it? Density. And so we can substitute. We can substitute. That's density. Okay, if it's density, and we use this ideal gas law to determine density, this is just, we put it over here, it's another variation on 5. And if you don't want to stick another one in your ever-increasing list of stuff to know, you can always derive it. But it's pressure times molecular weight is equal to dirt, DRT. Okay, so if you need the density of some gas, this is a great way to get it. However, when you work it out, there is a little trick. What are the units? What are the units here when you work it this way?
Grams over milliliters.
Grams over liters. Grams over liters, because remember working here and working with that R, volume had to be liters. So, let me take you back. Density, you saw this number, don't bother to write this stuff down. Density of air. When I first started chapter 12, I said it is about 1,000th of a gram per milliliter. Well, that makes it about 1 gram per liter. And so generally for gases, just so that we work with nicer numbers, we go to grams per liter for gases. Now let me take you back. Density. When you were in chapter 1, we worked a whole bunch of density problems, and when you did lab 4, we did density. Density back in chapter 1. Timothy, how did we define that?
Mass divided by volume.
Mass by volume, and our usual units back in those days. Do you remember, Timothy?
Grams over milliliters.
Yeah. Or sometimes we use grams over cubic centimeter. And of course it's the same, because 1 cubic centimeter is a milliliter. Okay. Now, this is not important for test 3, but it's important for the final. Okay, if you're working a problem from chapter 1, you're probably working with a liquid or a solid. And if they give you the mass and you give you the volume, fine, you're great, just go with that. But if you get something like that, you got to have a different approach. Because let's look at problem 1211. Calculate the density of nitrogen, oh, you name it. NO what? NO2 is called what? Is it nitrogen oxide?
Nitrogen dioxide.
Good. Nitrogen dioxide gas. We have at 1.24 atmospheres and 50 degrees Celsius, we want the density. You don't see grams there, and you don't see volume there. So if you were thinking back to just that, you are out of luck. So think dirt. And so we can use this equation and use that for any gas. Now, it would not work for a solid or a liquid, obviously. Okay, but it will work for a gas. So, our pressure, is 1.24 okay to use, or do we have to make any conversions? Is it okay?
Yes.
Yeah, 1.24 atmospheres, right units. Okay, I need a molecular weight, NO2, and I want it to the nearest 10. Anybody have, Aaron, do you have it punched? NO2. Hit it. Don't, no fear looking at my notes. Hit it. Russell, you got it?
46.0.
46.0, and that would be grams per mole. If I was careful and put all the units down, then we've got D. Okay, let's hear R again. Anybody? Everybody.
0.021.
Oh, wait, 21. Good. And the temperature is 50. Do I stick in 50?
No.
No. What do I stick in, Bruce?
Okay, so 323
3.
Kelvin.
23 Kelvin. Okay, now, always do a unit check. Atmospheres, check. Okay, here we have molecular weight, grams per mole, which it always is. Density, Here we've got R, we know those units, and here we have Kelvin, and you're going to very carefully solve for D. And again, if it's problematic to you because our unknown is on the right-hand side, and you're used to it, the X in algebra being on the other side, turn this whole thing around so you don't accidentally get the inverse of the answer. So let's go for density to the correct number of sigs, and then think units. Let's punch. Nina, you got it already?
Yeah, I got 2.15, or I guess 2.2.
But how many sigs?
2.15.
2.15. And what are the units, Nina? Andrew, help her out.
Grams per
Units,
liter.
please.
Grams per liter.
Grams per liter.